Hey guys, today we're going to start Unit 14. Okay, Unit 14 is over pyramids. Okay, another three-dimensional figure. A lot of the things we talked about with prisms will carry over to pyramids. Okay, so we're going to start looking at a net of a pyramid and a net of a prism. So here is a net of a prism. That you've seen here on the left. This is a triangular prism. And the triangles are the bases, and then the rectangles are our lateral faces. Okay. Now let's look at a net of a pyramid. So this one is a net of a square pyramid. Okay, and the base is the square, and that's how we name the pyramid. And notice that these lateral faces are now triangles. Okay, the lateral faces are our triangles. All right, let's look at first our net and some separate parts, some individual parts. So we've got our base, we've got a lateral face, is that triangle. This edge here is our lateral edge, or a lateral edge. Okay, and this looks like it's pointing to a vertex, but we're going to say this is a base edge. All right. Now, the height of a lateral face is called the lateral height. Okay, so the height of a triangle, that is the lateral face, is a lateral height. And that's very important because with a pyramid, we're going to have more than one height. Okay, so let's look at the three-dimensional representation. So we have the top of our pyramid, and that is called our vertex. Okay, and then again, this is our lateral height, and we're going to use a lowercase cursive L to symbolize that lateral height. And then this other height, notice how it goes from the vertex to the base, perpendicular to the base. Okay, this is simply called the height. And know that this represents the height of the pyramid. Okay, the height of the pyramid. So you need to know what both heights are. You definitely need to know which one to use where, because later on I'm going to use both heights. We're going to use both heights, all right? All right, let's do some comparing, okay? So we have prisms versus pyramids. So there's some similarities. All right, we name both of them by the base. Whatever the base is, that's the name. Okay, that's the name. Both have the same number of lateral faces as the base does sides. Okay, so however many sides the base has, that's how many lateral faces there are. Okay, now here, so that's pretty much where it ends with similarities, other than they're both three-dimensional also. Here are some differences. Okay, prism's lateral edge is the height of the prism, but not in pyramids. Okay. Pyramids have one base, while prisms have two bases. Okay, two bases, all right? Pyramids have a lateral height. I can't spell. A lateral height. And another way that you're going to hear me say this, or you could see it, is called a slant height. Okay, lateral height or slant height. In pyramids, lateral faces are isosceles triangles. in prisms, the lateral faces are rectangles. Okay, rectangles. All right, so those are some similarities and some differences. All right, so this next example, I want to be able to determine if the net will form a pyramid when you fold it. Okay, so I want you to do this, try this on your own, okay? And if it will make a pyramid, circle yes and then name it. If it will not make a pyramid, circle no, and make sure you're able to explain your answer. Okay, so go ahead and pause the video, and then when you're done, hit play. All right, let's see how you did. So A, yes or no, could that be a pyramid? Well, yes, it could. It has the same number of isosceles triangles that would represent the lateral faces as the sides of the base. And this would be a square pyramid. Okay. B is no. No, cannot be a pyramid. There's 5 triangles, and that's a hexagon, which has 6 sides. So that would not make a pyramid. Okay. C, yes, that wouldn't. That one's kind of tricky. Yes, that would. It would make a triangular prism. Prism was last chapter. Triangular pyramid. Okay. So recognizing what figure the net will make. All right. All right, next page. It says name each of the following. Okay, first name the vertex. Well, the vertex is a point. Point E is the vertex. Okay, then it says name the lateral faces. Okay, name the lateral faces. Well, the lateral faces are triangles. So we have triangle ABE, triangle BEC, triangle CED, and finally triangle ADE. Okay, and those aren't the exact answers. You can name a triangle with any order of the letters that make up the vertices of the triangle. Okay, and just make sure you use the triangle symbol and you have all lateral faces accounted for. All right. Then our lateral edges. Our lateral edges are segments, so we need to name them as segments. So we have segment AE, segment DE, segment CE, and segment BE. Those are our segments, okay, that make up the lateral edges. Then finally, it wants us to name the base edges. What are the base edges? Well, they're segments also. So we have segment AB, segment BC, segment CD, and segment DA. Okay. And again, the order of your letters does not matter as long as they're correct and you have the correct symbol. All right. So naming the parts of a pyramid. Okay, finally, example 3. Okay, pretty short notes today. You guys should plenty of time to get finished with your homework. It says find the indicated values. So find the slant height or the lateral height. Remember, slant height, lateral height, they're synonymous. So we want to find that. Okay, we want to find that. All right. Well, I'm going to draw that right triangle. Over here to the side, 2-dimensional figure. So this height of my pyramid is 8. This piece of that triangle would be 6. And if we wanted to find that, we would use the Pythagorean theorem. We know 2 sides of a right triangle. So I have 6 squared plus 8 squared equals L squared. So we got 36 plus 64 is L squared. 64 and 36 is 100. Square root of 100 is 10. Okay, so the slant height is 10. Okay, so remember, we got to remember all that previous math that we've learned this year. Pythagorean theorem, special right triangles, formulas for area. Okay, so there is 14.1 notes. Get going on your homework. You can check your answers online when you get finished.